Tires. They give you grip and speed, but they also pollute the environment, especially on electric cars. Why is that? Every year, around 6 million tons of particles from tire wear, a major source of microplastics, enter the environment from tire abrasion. In Europe alone, the number is estimated at 500,000 tons. And get this, more than 2 billion tires are sold every year, according to estimates.
90% of emissions today don't come from the vehicle's engine, but from brakes and tires.
And the trend is rising. Why? Simple physics. Vehicles are getting heavier, and more weight means more abrasion. Electric vehicles play a key role here. They typically add 300 to 500 kilos compared to combustion engine cars.
Everyone is being encouraged for climate change reasons, essentially to get very big, heavy cars.
So, could electric vehicles actually be the bigger polluters when it comes to tire wear? That might sound surprising at first, but let's dig deeper.
Welcome to the electric car of the future, sponsored by the gasoline producers of America.
EVs are often promoted as the clean alternative for tomorrow's mobility, and in terms of exhaust emissions, they largely are. But these emissions aren't the whole story.
Actually, 90% of particle emissions today no longer come from the vehicle's engine, but from non-exhaust emissions.
Since the 1990s, most exhaust emissions have been falling. At the same time, non-exhaust emissions, including those from tire wear, have been rising. Tire wear is now considered one of the largest sources of microplastics in the environment. In Europe, it's thought to account for around 500,000 tons per year, while globally the figure is roughly 6 million tons annually. Does this mean we're simply replacing exhaust emissions with non-exhaust emissions? Let's take a closer look. For starters, every car uses tires, and every tire wears down. Tire wear is simple physics. Where rubber meets road, friction occurs. Abrasion is especially high during starts, stops, and turns. The hot spots are intersections, traffic lights, and curves. Where does the tire wear go? Most of it stays on the road and mixes with other materials. Scientists call this tire and road wear particles, or TRWP. A tire is made of natural and synthetic rubber, carbon black, heavy metals, fillers, and other chemical compounds. As tires wear down, these substances, along with microplastics, are released into the environment. Rain washes much of this material into road runoff, where it can enter the water cycle, while lighter particles can become airborne. Despite many unknowns, we do know that fine particles can be inhaled and may cross the blood-brain barrier, posing potential risks to human health. Residues from tire wear have also been found in lettuce, meaning they can enter the body through the food chain. In aquatic systems, compounds from tire wear can have severe or even fatal effects on some species. Research is still ongoing, but one thing is clear: tire wear is harmful. So why might electric vehicles be worse in this regard? Again, physics provides the answer. The heavier the car, the more the tires wear. And this is where electric vehicles come in. Almost all EVs are heavier than comparable combustion engine models. Some passenger EVs weigh 300 to 500 kilos more, while the heaviest one, the Hummer, tips the scales at well over 4 tons and requires a truck driver's license in the EU. Some experts warn that as more EVs hit the road, tire wear emissions could increase. They say an EV tire could wear 20 to 30% faster. An Organization for Economic Cooperation and Development scenario suggests greater uptake of EVs could lead to a 52.4% increase in non-exhaust emissions. In 2020, Nick Molden, CEO of Emissions Analytics, sparked public debate on tire wear, and it wasn't without controversy.
Where we're going at the moment, particularly in Europe, is in a bad direction, is because everyone is being encouraged for climate change reasons, essentially to get very big, heavy cars. And that's leading to all sorts of other undesirable side effects. And probably the biggest of all is tire emissions.
Promoting electric vehicles is the wrong approach, says a German aerodynamics professor.
Because they are heavy, and that's why these cars, they invoke only problems for us if we look in the direction of tire wear particles. They do save us from some brake particles by recuperating the energy.
But car makers and the tire industry also admit there's a problem.
What we see with electric vehicles is that they typically are going to be heavier than traditional internal combustion engine cars, and they also have that immediate torque, so they move off more quickly.
If you compare an internal combustion engine to an equivalent electric vehicle, the difference is probably 20-25% more weight. So it means that an electric vehicle with 20-25 more weight will emit 20-25% more particles per kilometer driven.
So why are EVs so heavy? Performance and range are key selling points, but the longer the battery range, the heavier the battery. And that extra weight adds up. Battery capacities have increased steadily over the years. But EVs aren't the only heavy vehicles. There's also a broader trend towards larger cars. In recent years, nearly half of new cars sold have been SUVs, which are typically heavier than standard passenger cars. Studies show that vehicles are increasing year after year in height, weight, length, and width.
We can see this trend, I think, for decades now. Of course, we are working heavily to compensate it somehow, right?
Another factor accelerating non-exhaust emissions is rising global motorization. By 2050, the number of cars could increase from 1.6 billion today to over 2 billion. According to one estimate, electric vehicles could make up nearly 70% of the global fleet by that time, though other projections are more conservative. There are many factors driving this trend, and depending on who you ask, it's down to consumer preferences, safety rules, or the car makers themselves. No matter how you look at it, tire wear is a major problem, and the heavier the vehicles on the road, the worse it gets. But amid all the blame, we shouldn't forget that electrifying the vehicle fleet helps reduce greenhouse gas emissions and combat climate change. So how can we enjoy the benefits of transport electrification while limiting tire wear? Solutions range from vehicle and tire designs to regulation, taxation, and end-of-pipe technologies.
Or a possibility to avoid these kind of particles is not to put more electrical vehicles on the road, but to think about to build them smarter. And that is, for example, to build them lighter. And this is difficult as long as we stay for our normal horizon of luxury.
France, for example, has recently introduced weight-based taxes on cars, and other countries may follow suit. On the regulatory side, the European Union's Euro 7 standard will soon come into force. Euro 7 is the successor to the Euro 1 through 6 standards, which were introduced starting in the 1990s and succeeded in setting limits on exhaust emissions. But today, those emissions are no longer our biggest problem. For the first time, Euro 7 will include tire wear limits to improve air quality and reduce microplastic pollution. A tire can lose roughly 1 to 2 kilos of its mass over its lifetime. Worldwide, more than 2 billion tires are sold each year. Now imagine your car stays on the road for 300,000 kilometers. If you change your tires every 50,000 kilometers as recommended, you'll have released almost 24 kilos of microplastics and other chemicals into the environment. But here's where it gets complicated. We don't know exactly how much mass a tire loses. Tire wear is difficult to measure, mainly because it happens out on the road, not in a controlled environment, and particles spread to a multitude of locations. Although various tests for tire wear exist, there's still no standardized measurement method. This must be established before the Euro 7 standard can be fully implemented, and disagreement remains. If Euro 7 comes completely into force, tires that don't meet the requirements could be excluded from the EU market. Industry estimates suggest roughly 30% could be banned, potentially reducing total tire wear emissions in the EU by around 10%. The regulation would apply only to new vehicles, leaving countless tires already in use unaffected. Car makers and the tire industry are insisting on a standardized test method before introducing Euro 7, and they're mainly the ones defining the standard in various working groups.
The test method is critical, because if we don't test properly, we won't have the reduction that we are talking about, the 10%.
And because Euro 7 focuses primarily on limiting the total mass of tire wear, other types of emissions could remain unregulated.
That could, however, lead tire manufacturers to design tires that produce less tire wear overall, but instead generate smaller particles that may even be more harmful to human health.
While political debates continue, tire abrasion enters the environment every minute, and once it's there, it doesn't go away. Scientists at Berlin's Technical University are working to capture it in order to help protect surface waters.
The last chance to capture the tire wear is in a road gully, in a road runoff. So we developed a filter system, and we could show that it's 97% of all the particles can be captured, and 77% of quite the fine particle matter.
Based on these results, the group is running pilot projects in various cities. In Copenhagen, for example, the urban filter system captured more than twice as many solids and microplastic particles from runoff compared with standard drains.
If we start installing filter systems, we should start at intersections and curves.
But how many filters would we need to remove the vast amount of tire wear? Remember, an estimated 500,000 tons exist in Europe alone. Still, these filters could help tackle the problem in the worst affected areas and are a good starting point. About 250 kilometers from Berlin, scientists at Ostfalia University are aiming to manage particles before they enter the environment. How? Professor Falk Klinger and his students have developed a method to track how particles flow during friction, using a self-made wind tunnel and laser technology.
With our investigations here, we were able to capture in the middle of the wheel something like 85–90% of the particles. So at the rim of the wheel, that means very close to this part here. Normally, we won't be able to do that. But it will be issue of the next years to produce some more, some more sophisticated systems.
Once researchers better understand the aerodynamics of the wheel, how particles travel in the airflow, and how they can redirect them with a nozzle, it'll be possible to guide those particles into a filter. Japanese tire giant Sumitomo, which also owns Dunlop, has expressed interest in this approach and is now collaborating with Professor Klinger. While capturing tire wear with filters is one possible solution, the tire industry is also working to improve tires themselves, designing them to handle the demands and weight of today's heavier vehicles.
It takes innovation, in fact, and reflection to understand how you can improve the performance of the tire, especially in the emission of particles. And we have designed and we have worked a lot on the design of the sculpture, the drawing outside the tire that is in contact with the road, but also on the materials. And that's very important because this is really the key of the performance.
Michelin claims they were able to reduce their tires' abrasion by 5% between 2015 and 2020. And by 2025, Michelin aims to replace all fossil-based components in its tires with renewable or recycled alternatives. Another less appealing solution for the automotive and tire industries would be for people to drive less.
We have also measures in terms of the chassis setup, for instance, of the vehicle. Audi is heavily involved in the development of driver assistance systems, for instance, that support the driver to ensure a smoother driving behavior and profile. So no aggressive acceleration, deceleration, and also cornering, for instance.
The tire industry, meanwhile, is appealing to individuals and communities to take responsibility.
We need to take into consideration driver behaviour, we need to take into consideration the quality of the road surface, and as we mentioned, we need to think about sometimes the weight of the vehicle as well.
One thing is clear, we can't avoid tire wear and we need solutions. The heavier the vehicles, whether electric or combustion engine, the more tire wear they generate, and this will only increase as heavier cars become more common. What do you think? Leave us a comment and don't forget to subscribe.